Hey guys, so this is how I solved problem number 28 in the textbook. So as you can see, here's the diagram on the left. So torque equals force times the moment arm or force times the radius. They're the same thing. So you've got the sum of the torques. If you put the sum of the torques equals 0, that means that whenever you solve out the equation, if it doesn't equal 0, that means that this arm is in motion. So that's what we're going to do. So we're going to say the sum of the torques equals the torque of the muscle plus the torque of the forearm plus the torque of the ball. Okay, so we'll just plug all of these in. So you've got 0 equals, we're going to plug in force times moment arm for all of these torques. So the force for the bicep muscle is going up, so it's 500 newtons. Here, let's change colors. So 500 newtons times, now we've got this in centimeters, so 2 centimeters, 100 centimeters is 1 meter. So you can divide 2 divided by 100, or you can just move the decimal places over 2 times. So it's going to be 0.02 meters plus the torque of our forearm, which is 32 newtons times 0.18 meters plus the torque of the ball, so it's 20 newtons times 0.28 meters. Okay, now then, with this 32 newton, it is going in the downward direction. So this is going to be a negative force there. You've also got the 20, which is going down, which is also going to be negative. So you've got 0 equals (10) Newton meters plus a negative (5.76) Newton meters plus a negative 5.6 Newton meters. Okay, so if you calculate that out, you know that it's going to be a negative because these two add up to more than 10. So you've got 10 minus 5.76 minus 5.6, which means that there is a negative 1.36 Newton meter torque. So if it's negative, that means that it is going in the clockwise direction, which means that the muscle is eccentric. Now, the mechanical advantage takes some calculations. You can't just use the distance on this one because you've got 2 different forces. Okay, now we know that the mechanical advantage is going to be somewhere in between these 2 vectors. Okay, so if we calculate for the force to make it isometric, that's how we can calculate the mechanical advantage. So let me explain. If you've got your torque of your muscle plus the torque of gravity plus the torque of the ball, equals 0, that's when we can actually calculate the mechanical advantage here, because we've got two different forces going down. So we want to find the force of the muscle that makes the rest of this equal 0. So we've got force of the muscle times the moment arm of the muscle plus the force of gravity times the moment arm of gravity plus the force of the ball times the moment arm of the ball equals 0. So we're gonna move this and this over to this side. So we subtract. So we've got the force of the muscle times the moment arm of the muscle equals a negative force of the gravity times the moment arm of the gravity minus the force of the ball times the moment arm of the ball. Subtract by the moment arm of the muscle, divide by moment arm of the muscle, and that would equal the force of the muscle equals all of this. That's times. So if we plug and play here, we've got the force of the muscle equals a negative force of the forearm, which is a negative 32 Newton times 0.18 centimeter, which we already know this because we've already calculated that up here. And then we've got a minus a negative times a negative 20 newtons times 0.28 meters all over a positive 0.02 meters. Okay, so this is going to be the force of the muscle equals a negative minus a negative 5.76 Newton meters minus a negative 5.6 Newton meters all over 0.02 meters. Okay, so these negatives cancel out. Okay, so we know that 5.76 Newton meters plus 5.6 Newton meters equals 11.36 Newton meters all over 0.02 meters. So the force of the muscle equals 568 newtons of force to hold this ball right where it is. So this, if this equaled 568, that means that we could hold this ball against gravity. Now we can calculate the mechanical advantage using that equation. So your mechanical advantage equals, the book gives us the effort arm over the resistance arm. There's another equation which is the resistance force over the effort force. So we can't use this because there are two forces here. Okay, we have to use the force equation. And in order to use the force equation, we have to find out where it's not going to be in motion. So just plug and play. Mechanical advantage equals the resistive force, which is our 568 newtons, over our resistance. Our resistance is 568 newtons. Our effort force is our 32 newtons plus our 20 newtons. So if we calculate that out, so if we have 568 divided by 32 plus 20, that equals a mechanical advantage of 10.92. Okay. Now, does that make sense? If we use the book equation, if we use this equation to find the mechanical advantage of each forces, it will be around here. Let me explain. So if we use the book equation, we've got the mechanical advantage equals the effort arm over the resistance arm. So we'll use the first one, the effort arm would be the forearm. We'll use the forearm first. So, and that was mechanical advantage equals 0.18 meters over the resistance arm, 0.02 meters. And that equals 9, mechanical advantage of 9. Okay. Now then, we've got the effort arm of the force of the ball. So that's mechanical advantage equals 0.28 divided by 0.02. That would equal, oh, I didn't write it in, 0.28 meters over 0.02 meters equals 14. So we know that the mechanical advantage has to be somewhere in between here. Okay, so that means that the mechanical advantage is somewhere in between our 32 Newton force and our 20 Newton force. Since this number is bigger than this number, it makes sense that it's not going to be halfway in the middle. It's going to be a little bit toward our gravity of our forearm. So I hope this helps. I'm not sure if that's exactly how she wants us to solve it. Hopefully we'll see today. I hope this doesn't confuse anybody. If you have any questions, just let me know.